Friday afternoon. I hope you're all fine. You feel comfortable so far? Yes, everyone is a bit tired, but it remains exciting here. Hans Viehmann is here today with us. He is working for Oracle Corporation as Director of Product Management for Spatial and Graph Technologies. He's leading a global team of product managers responsible for Oracle's geospatial products. Today, he will present how Oracle customers use the capabilities of microservices to improve software development. Welcome, Hans Viehmann. The stage is yours.
Okay, perfect. Thank you very much. Can everybody hear me reasonably well? Great. Okay, that looks good. As I said, I'll be talking about the advantages of using graph technologies for the purpose of impact analysis to start with, and then I'll also touch on legacy software modernization and the like. I am, as we just heard, product manager. I'm based out of Hamburg in Germany, and I'm just so happy to be back at SDS, particularly here in the beautiful city of Zurich. So thanks for having me again. In the few minutes I'd like to briefly talk to you about, as I said, impact analysis. And there are different definitions, obviously, of impact analysis. And so in order to give you an idea of what I'm referring to here, just for the moment, imagine that you're a project manager, you're rolling out your new software release, right? And in that new software release, you have changed the definition of some table in your infrastructure, and it's Sunday night, you're testing things, everything goes well. Monday morning, users start working, everything is good until Monday night, the monthly report kicks off and hangs because of your change in the infrastructure. Next morning, CFO looks at his balance sheet, and the balance sheet is empty. Now, I'm not sure what your CFO typically does in these cases. Maybe it looks like something like this. What's gone wrong? Well, obviously, you did not have the full understanding of your software infrastructure. You didn't have all the dependencies inside which you needed to take into account, and therefore you overlooked the fact that the report is dependent on the change that you implemented in your change. Right? Of course, figuring out these dependencies is a pretty complicated task, right? I'm sure you have a software architecture which looks a little more tidy than this, but even so, even if it's tidy, it is still it can be a pretty daunting task to figure out all the dependencies in your software infrastructure, and you can't really do that without a certain level of automation and tooling. And one technology which is particularly helpful in these cases is graph technologies. So if you represent this software infrastructure as a graph, where let's say every component, every module you have is represented as a vertex or a node in the graph, and every relationship is represented, or every dependency is represented as an edge, then you can determine the dependencies very nicely, because you just need to follow all the links in your graph. So if you change something in the top right, you can figure out whether in that central piece there is any dependency. Your dependency analysis essentially becomes a pathfinding exercise, and graphs are just ideal for these kinds of purposes, right? Whenever you have data structures which are either networks or, like here, what I was just showing, or hierarchies, like in the case of privileges and access management, for example, then you can nicely do pattern analysis or pattern matching or link prediction or the like on these types of data structures. Graphs are just great if you take into account the possibility that you explicitly store the relationship as a first-class object in the database. Then you can essentially do fast traversals, which give you shortest path analysis. Circular paths is something you can identify very nicely. You can do any kind of connectivity, link prediction, and so forth. Right? So that's what graphs are great about. Now, until 1st of June, there was no formal standard for a graph query language. But that has changed, and not many people, I think, have actually realized that. On 1st of June of this year, the new SQL 2023 standard was published. It was published as a draft in autumn, and it's now published officially And as part of that, there's a completely new section, part 16, on property graph queries. So we've come together with our colleagues from Neo4j, from Amazon, from ArangoDB and DataStax, and so all the sort of key players in the industry, and we've defined a pattern matching query syntax, which is now part of the SQL standard, making sure that there is interoperability between these systems. And if you want to try this out, there is a new version of the Oracle database, the Oracle database release 23C, that we have launched a couple of weeks ago, and that already implements this specification. So you can perform graph queries in SQL. That's actually interesting because now every tool and every application that knows SQL can use graph features. And that allows you to do pretty sophisticated things. I mean, essentially, it gives you a different view on your existing data, right? And we've used that capability in a legacy modernization project where the idea was to look at the data model in the database and then split it up in such a way into software, into sort of independent units that could then be represented as microservices. And if you think about it, in a relational database, the data model is essentially a graph. Right? You have all these tables, which are essentially the vertices in your graph. You have these primary key, foreign key relationships, which give you the edges. And on top of that, you can actually do analysis how these things hang together. Now, the data model alone doesn't help you that much, but if you complement that with analysis from a load analytics, a workload analysis exercise, which good databases can essentially do in an automated manner, then what you get is the SQL queries, and the SQL queries contain, of course, the information about which table did I join with which other table, which gives you a measure for closeness or a measure for the interaction between these tables. And then graphs come into play, and you can run algorithms from graph theory, in particular like community detection algorithms, which allow you to, in an automated manner, suggest a data model which is sufficiently disconnected so that it would split up your data model into good candidates for microservices. And that's essentially what we did here in this little example. You can see, okay, we have the sales context, which is centered around the business opportunity, and you have the services context, which is centered around the service request. And these tables are typically used together in conjunction with one another, but rarely do they cross domains, and there you would only have an API call. So that's a nice candidate for a microservice that minimizes the indirect interaction between these two domains. Right? This is just one small example of how graphs can help you to develop better software, essentially. Right? Many data structures in software infrastructure can be represented very nicely as a graph, whether it be software modules and classes, or roles and privileges, or if you have workflows or data lineage and so on. And you can analyze the direct or the indirect relationships between all of these entities, right? And last but not least, you can, as you can see on the right-hand side, you can also use graphs very nicely as a communication tool, right? For discussions between developers and architects, for example, or to convey like security things very easily. That's sort of one little side effect of what graphs are useful for. And now that graph queries are part of the SQL standards, I'm sure we'll see a significant proliferation of these kinds of graph applications, right? So if you would like to learn a little more about how we are using graph technologies, or how our customers are using graph technologies, feel free to come and see us downstairs at the booth. I have two colleagues from the Oracle Labs here from the team which is based in the Prime Tower. We also have Thierry here, who is leading the EMEA business value team, who is also interacting with lots of customers. He might have interesting insight into all kinds of things, so feel free to ask him about whatever you would like to do in your software infrastructure as well. And with that, I hope in the few minutes that I had, I have at least given you a bit of an idea of why we're using graph technology and why we find them so important. Thank you very much.
Thank you very much, Hans Viehmann. Maybe one question, which benefits will be, achieved for the customers?
Okay, so that, of course, is a very broad question because it depends a lot on what customers we're looking at, but we see a lot of use cases in the financial services industry where customers are using graph technologies in the context of fraud analytics. For example, figuring out whether there are circular money transfers, right? You have an account and money goes from this account, from account A to account B to C to D, maybe back to A, which is kind of suspicious. Why would money move around in circles? Right? That always looks like money laundering. These types of things are what banks, for example, use in their department. That gives them a lot of added value, obviously, to counter fraud. But there's also lots of use cases in software infrastructure, in IT management, and the like. Wherever you have interconnected systems, it's just a very broad topic.
Thank you very much for being here for this short speech. If you have further questions, don't hesitate and contact Hans Viehmann. He's down at the booth, as you said. He'll be here for the whole conference, or maybe you can email him too. Yes. So it's time for a little break. We see us at 3:45 again. Have a little chat, have a coffee, make yourself fresh. See you soon.